Today our first topic will be to retrieve data using the labels. Okay, let me import up the things. Fine. So see, let's say that I'm making a series, pd dot series, and let's write 10, 20, 30, and 40. Okay, and we'll just say that my index are going to be np dot array, and then I'm going to make it as a b e c d dot split. Right, cool, done. Let's run this. So that's my S series. So I look on my series, that is ABCD, and so does the values are there 10, 20, 30, and 40. That's nice, right? Now, what is retrieving data using indexing kind of thing? What is that? If I say that I want to find what's there in the C, so print S of C, you'll get 30, right? Similarly, we can retrieve data with the multiple elements, right? We can write in the S, even let's say A, let's say C, again A, like that. What is there? Oh, you'll have to actually make a two brackets there. So you'll get the values. So in A10, the C30, the A10, okay, like that. So this is like retrieving data from your series, like you whatever you make, you proceed with that. Okay. Now there are several other methods, like yesterday we discussed regarding the NaN values, I think, right? If I make a series, so this is my S, which is having 4 elements, and so does the things are right. Okay. Now let's copy this and pasting up there, giving it as S2 and making it as 100, 200, 300, 400, and making a NaN there. Okay, 5 values. So my S2 would be 100, 200, 300, 400, and NaN, obviously, right? Who was there? Okay, so it was 100 to 400 and the NaN then. Now if I say that I want to add up this S plus S2, what you can see, this is 100 plus 10, 110, 210, 310, 410, and the fifth value is NaN here. And what about this? Because see, in the S you only had 4 numbers, and in the fifth you had like in the next series you have 5 things, right? Exactly 4, right? The fifth one is not a number exactly, so there's no probability or no such things, right? You can't add anything with nothing, right? Because there is something NaN. Okay. Oh, let's say if I even remove this, if I say 500 here, what is that? exercise. Oh God. Alright, so my S2 now comes as, this is S. Okay, should be S2. So this is 100 to 500, right? And this is my S. That is 10, 20, 30 and 40. Now see things clearly. This is having 4 elements and this is having 5 elements. Now I'm adding 4 elements with the 5 elements. Obviously the last element is going to be an AND, because see, you don't have any fifth element in the first one. So how could you add some fifth, how could you add the values with the fifth element? There is no such possibilities, right? So that's why we are getting NAND, because there is nothing to add up, right? Similarly, you perform any mathematical operation, let it be multiplication, divisions, or anything, right? You'll be getting the same things there. Okay, like you see, rent s minus s2, you'll be getting an AND. Okay, got it, right? So similarly, we can find even some of the basic statistics part, like median, mean, the sum, the minimum value, the maximum value, the modes. Modes can be done with the SciPy, basically, statistics over there, right? So, like whatever the series is there, you just write like print np dot mean of this s. Let's say I think left 1, 2, 3, 4, 5 minimum. So does the results are there 25, 25, 140 and 10. Got it? Otherwise, you can easily like write it as max of s, min of x. That's also the same thing. Okay, so that's like what we can do with the help of a series. So like whatever we deal, that a series can be made with any vector things. Like it can be made. There can be an empty series even. No, right? There can be an empty series. If I say pd dot series, that's it. So this is an empty series. Okay, and by default, what's the data type you get? Float 64 always. So you can create series with an NumPy array, you can create with a dictionary, you can create with a list, you can create with the tuples, and a lot of things, right? You can do with some of the bit operations we did also yesterday. So let's come in the data frame part. Okay. Now we discussed data frames are a 2D structure, labeled structure, right? There we have some rows and some columns specifically, right, to like make a kind of an Excel sheet type of, okay, and we can convert and we can load, read data with this data frames, right? So what is the syntax of this data frame? You write your data name, you write the index. If you want to define your columns, you write it. You want data type, you define it. If you want something from your data to be the index column, you can define that. Okay, these are the things, right? A basic structure I have given you, right? Okay, let me show you how. Let's say I'm making the stuff census report. Okay, and I'm saying that this is a dictionary. The dictionaries are very important when you deal with the data sets. Let's say this is country. let's say this is capital. So you can see what I'm doing exactly. Okay, that's a small dictionary, right, for census. Now what I'm doing, let's take, I have taken a variable name as df, and I'm going to create a data frame. So when you create a data frame with a dictionary, there is no such requirements for writing index and the columns and all, right? Because the index would be the things exactly, and the columns, like if you want to define index would be by default it would be 0, 1, 2, 3, and it will be going through that. If you want to define your columns, you can define that too, right? Okay, right. So but by default your columns would be your keys of the dictionary. So my data is the census, and you want to define your index, you can define, right? Census is not so if I just show you this df, what you can see there, just some kind of a data frame, Excel sheet, you can say. See these three keys, the country, capital, and population, to be your columns, right? The 1, 0, 1, 2 to be your index, and the rest, the values, to be there exactly. Okay. Now, moving next. All right. Now, see why we deal with the series, because series are important. From a data frame, you could be asked that how to make a column as a series. If this is a column, country is a column, capital is a column, population is a column, then how to make a column in a series, right? What you can do in that place, like we want to convert any column in a series, what we can do is we can just write that in the df we want to search for one particular column, that is, let's say, country, and that's the series. See exactly this, what you get in the series, the name of the series, the data type, and the values. Got it, my points? Okay, fine. So data frames are a two-dimensional array, and these contains basically the heterogeneous kind of your data. Okay, fine. So let's make a data frame now. I think one of the thing is might be there in the dictionary. I'll just show you once. Uh, Kind of a nested dictionary. What we can do with that? When that is a dictionary, nested dictionary. This is list. Okay. So if this is list, then date 10 would be, I think, the dictionary one. Sets 11. Hmm. See, this is one kind of a nested dictionary we are having, okay, and I'll just show you that what we can do with this. Now, so this is one of the thing of the real-time data, that is batting average of the Indian players, and I think it's this for the ODI or T20 might be is kind of okay. So I'm saying batting average, okay, and what you can see that there are some several keys and several values inside one particular key. But you should make sure that whenever you are giving the values in your dictionary, it should be very clear that the values are of the same length. Same length means that if there is 14, then there must be something 14. There must be also 14. So length of your arrays should be equal. Okay. So this is batting average. Now, see guys. So if I look on to my batting average keys, what are my keys? So this player span, matches, innings, numbers, runs, and all these things, higher scores, average, batting, and strike rates, and 150, 0, 4, sixes, and all these things would be your columns. Okay, these are going to be your column, right? You'll be finding this as your column, and these all keys will be your columns. Sorry. This all will be your values, and this all will be your columns. Okay, right. Okay, fine. So these are your basically column names, players, span, matches, innings, and all. Similarly, if I just go, so I'm not going to print the values because that will be a quite big thing. So only to get the some bit of data, like in the batting average, what are the number of sixes? So these are the number of sixes of the respective players and all like thing. Okay. So let's quickly make a data frame of that. Let's say batting average. So let it be BAVG. One second. So let's take this as only B, VT, and let's make a data frame where the data is going to be batting average, and the columns, how many columns are there? Index values are almost 1, 2, 3, 4, 5. 5 and 2, 5, 1, 2, 3, 4, 5, 25. 25 minus 2, 23. 25, 23 are there. ABCD, no. Okay, fine, let's write it there. So now see, this is your BT, right? That is a data frame of all these things. Now you have deal with some of the kind of very less difference. If I just write the BT, what you will see a total complete data sheet, right? With these things, you make a complete total data sheet. Got in my points. Now see, always I don't want all these things there in my data set. I don't want all these things to be there in my data set. I'll not be working with every of the thing, right? So what I'm going to do, like if you want to see the top 5 players and something like that, right? So see, if you want to find only a specific thing, whenever you load a data, the very first thing is to find out the information of that data. So this is like first to go with print. Okay, so you can see the information. This tells that there are 23 entries starting from 0 going till 22. Data columns are 15. Okay, and there the column names are there, and there are no null values, and the data types has been given. The memory usage is 2.8, and all the things you have got there. Okay, so if you just write the bt dot memory underscore usage, so you'll get the respective things, memory usage of respective things. So there are 23, right? 22 of them are 184. So 184 multiplied by 24 plus 128, 4544, and you can see the memory KB is 2.8 KB, like 455 bytes. Okay. So individual in the bytes, you have got all the values. Player is taking 184 bytes, span is 184 bytes, and such the things has been defined there. Okay, fine. Now, so if you write that index, you don't want the index. So you are not going to get the value for the index, right? And such the things. So write t equals false. So according to that, you'll be getting other things respectively, right? Okay. So this is like one of the such important method for finding first the information of your data. Then you go for a statistical for your data. So we use describe function to get a statistical description, like kind of this. Okay. So in the matches column, what is the number of maximum number of count, the minimum, the means, the standard deviations, the minimum value, the maximum value, the 75 percentile, 50 and 25. So that's the things. Okay. Or else you just write bt.describe would be giving you much better. So you will get the things like this. Okay. So for all the columns, you'll be getting a statistical description. If there are numbers and the floats and the complex, if there are string, obviously you're not going to get some statistical description for a string, right? Now, okay, that's fine, right? So I don't need every of the thing. Okay, I know I don't need all the things to be printed up there. So what I'm going to do is, I want to see only the head. Head means first 5 columns. Data set dot the head, giving you the first 5 columns of your choice. Not your choice, like head will be giving you the first 5 columns. Okay. Now you can write header 1 even. So if you want to see only one from the starting, it can give you only one. Got my points? Similarly, we'll get the tail. From the last 5 things you'll be getting up. Okay. Similar to this, if I write that bt dot tail of 1, obviously I'm going to get only one value. Got my points? Okay, right. So this is working of a head and tail, right? So overview of a data is given by information, right? Statistical given by your describe. So to find the number of columns in your data frame, how to find the number of columns in your data frame? What are the columns in your data frame? Exactly what are the keys in the dictionary? What we have made. So we can write both the things. For any data frame, we can find the keys as well as we can find the columns. Both the things will be working as same. Okay. Now to convert this in a list, we'll write bt dot columns to list, and you'll be getting a list of all the columns. Right? That's important. A list of all. For any values, what you get, you want to convert in the list, you can use this method, or you have another option, you can use this too. So by preferably you can use the list constructor method, that is list of all the things. Otherwise you can use toList and just toList and it would be done. Otherwise you can just write right. So I've given you the various things, the various options to convert up the things accordingly, to find the columns, to find the things. Okay, right. Okay, so to look on the columns of your data, you can just write up the things accordingly. And to convert them in a list, you can use this thing. Similar to this, you can convert to array, to tuple, to dictionary, such things. Okay, list is quite good conversions. Now, if you write that to look on the column values, you can just write print bt dot columns dot values. Again, you'll be getting the same thing, right? Columns values. This is also the same thing what you get here, but these will be a kind in the kind of a values without any commas and all. So these are the values of the columns. These are your column exactly, and this is also the column, right? Because if we see columns, what are column? These. So these are the values of the column. Got it? I write it right. If you use the parenthesis, it's not a like working, because many times students do this, right? So don't use the parenthesis, because these are not command for parenthesis, right? These are not, this functions does not need parenthesis, because this is not function basically, like kind of. These are operations, you can say. Okay. Now, next thing. Okay. Now we have find up the number of columns, the columns and all, like see the length of the columns and all. You can use the size and all things, right? Now to look on the index. So what are going to be the values of your, what is your index basically? So data frame dot index. So index starts from 0, stops at 23, goes with an stepping or an interval of 1. Now what are the values of this index? Zero, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 until 22. That's nice, right? And by default, what is the data type of this? What you're getting there is a kind of an array. Integer 64, right? We are getting up these things over there, right? Data type. And that is a pandas core index range of the things. All right, I think that is clear to you. That is an array, basically what you are getting up there. Thing. Okay. Right. Moving next. Or if I just write down these things in the down words, that would be nice. Okay. Yeah. Now we have got all the values from the columns, we have got all the values from the index. Now what are the values like if we want to see directly the values of your data set, right? Directly want to see the values from your data set, what we can do? So we can write there to see the values of your data, that's it. What you need to do, print your data frame dot the values, that's it. Now you can see all the values of your data set. So this M.A. Agrawal is having this values, R Ashwin is having this value, and so does the things would be clear, right? Everything would be displayed there respectively. So these are all the values. Now you can slice, you can use the things, right? So to find if there any null value exists in your data set, yesterday we did it the same, right? In the series, remember? So if we say to find or to look for the null values, so what we did yesterday to see any null values? Yes, answer. So what was the operation to see the null values? Anyone speak out quickly? To look on the null values, to find the null values from your data, what should we do? Is none. Okay. Any other option? Is null. Right. So what we are going to do, we will write pd dot is none, and we just pass this thing and run this. So there in the data frame is there no objects for is none. So what you can say is null, and it will work. So what I can see, all the things as a false, all the values of the complete data frame to be false, right? Why? Because there is no null values. If you see your info, like if we go in the previous one, if we see onto my info, yeah. So what your info says, this info says that there are 23 non-null, 23, 23, and there are so nothing is there inside this as null, right? Nothing is there as the null one. Okay, fine. So that means that it is complete non-null things, right? So if you look on to not null, it would be, so let's say guys, I'm not printing up the whole thing now. So I'm just going for not null, and I'm just looking the first 5 values. So not null will be true, obviously, because these are things, these are not null, right? Not null is used for checking for the not null values. Okay. Now if I see with a bt dot, so that is like say to get a sum of null and not null values of your data, what you write, print data frame is null dot sum. So you get everything is to be the 0. Similarly, for not null, it would be print sum. See, not null at 23. So everything is having a value and nothing is null over here. Okay?
So what is dot sum?
Dot sum. So this gives a sum of all these things, right? It's a count of all this sum. Right? True. How many true are there? How many false are there? For respective thing. Only discrete values will be there, either true or either false. So it goes for finding the number of the true and number of the false. Like if we make a data frame with some null values, okay, let's load a data frame. I think we are having one. Start a new call. Okay, let's create one something. Like let's say this is f random data. And let's take like we are going to make some 1, 2, 3, 4, 5, 6. Okay, these are going to be my index, let's say, or let's say these are like some of the x. Okay, and this is y. So y is going to be np dot nan, then 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, and let's say z is going to be 3, 4 np dot nan 5, 6. 1, 2, 3, 4, 5. These are the things. Now if I say make a data frame, okay, so df would be like let's take it something as first. D would be like here we're writing x, which consists the x. Then I'll writing the y, which consists y, and then I'll write z, which consists z. Okay, this is going to be a dictionary. So if I say that df2 is going to be bd dot data frame, and the data I write it as d there. Okay, it must be of same length. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Alright. Now if I look onto my df2, see what will happen, that I will be getting some 5 values, right? And you can see some nan here, right? Can you see there, right? Nan are there, something. Okay. So let's say if I take 6. So now what you can see that there are 2 nan in one column, 1 nan in there here, and there is no such nan, right? So now for this data frame, if I say that print, or even if I say that df2 dot is null, then obviously we are going to say get some true results there. So if I write df2 dot is null dot the sum, so it will say, okay, it will say that in the x there are no null values, in the y there are 2 null values, and in the z there is 1 null values. Clear?
Yes, sir.
Okay. Similarly for the not null, it would be like in the x there are no null, right? Not null 6 objects. In the Y, it is 4 not null objects. In the Z, it is 5 non null objects. Okay. So like that, you can get it. We'll be dealing with it. But, so with the nulls, we got it like that. With the sums and all, you can see like if it is a null or not null objects and like kind of. Okay. Similar to this, we'll be working with the C bonds. I'll be dealing with that, right? So let's import that. Not now, just making a graph. So heat map is just used basically as one of the most important thing to see some of the correlations and all. So if I just write df3, what is that? Df2 dot is null, and let's say the color map I'm going to use is the Vistia. And we could find there 1, 2, 3. What they say is that what this orange says, this 1. Okay, so discrete value will be getting up there, and in the 0 we are 0 means that this yellow means totally 0, right? And this orange mean ones. That is either true or the false, right? So 0 means false and 1 means true, right? So what are the true things? Where are the null values? In the Y column, we can see in the 1, like first value, that is 0, is a null value, and the fifth row value is also null. In the Z, the second row value is null. Let's see. In the Z, the second row, yes, the second row, that is third one basically. And in the Y, it says that the first and the last are true. That is correct, right? So like this color
Sir,
man, yeah, yes,
sir, draw the graph using not null.
not null. Okay. See. So for not null, 1 is true. So everything what are the deeper portion is not null. So what are null? What are the zeros? So these are null values. Got this? The difference?
Yes, sir.
Okay. Yes. So we'll be going through this heat maps and all. It's a kind of a plotting in the C1. We'll study C1, right? Let's see to change or let it be there. Coming up next. Okay. So if you have a complete non-null set, it would be something different, right? So for complete, let's say we have something BT, which is a complete one. So if I go for the heat map of like this, if I say BT dot is null, I might have written some wrong color mappings. Is the C small? Yeah. So we could find that this is 0. This means 0. 0 means that there is no null values, right? Like using something, what is that? I forgot his name. Spectral, I think it's spectral. NIPI spectral. Okay. Why it's NIPY underscore or spectrum. That's it. Like why is getting okay. So like we can find that it is complete a non-null thing, right? If it might be a null one, you'll be getting something different, right? So for not null, see guys, this is at 0. If I write for not null, it would be also 1. Now see, the things will be changed as the 0 and the 1s will be changing up, right? Down this is complete 1, right? I think that is clear to you. Now, so there are possible lot of values for a color mapping, right? What I am making it like color maps. There are a lot of color maps. Yeah. Okay. Now coming up to the first that batting data sets, right? If I look on to the head of one, if you remember the things like that. Okay. It's coming now. Going slicing over the data frames. How to slice over the data frames, right? Like if you want to get a specific column, for to get a specific column, I'm saying specific column. So that is also easy. Like first you write the data frame name and then you give some two brackets. Okay, that's to specify the data frame. So we want, let's say, player column. We want, let's say, matches. Let's say we want the strike rate. Oh, I only want the player and the matches and the strike rates and the runs. That's it. Okay. We'll run this and you'll be getting that respective columns. So let's say we want only the head, that is first five values of this, and see like the player name, the matches he played, the strike runs, strike rates, and the runs. Okay. Now to get a specific row, that's the issue, right? To get a specific row, so columns are very easy to find out, right? So to get a specific row, there is something you'll have to use the locate. Okay, you'll have to use this locate locations. All right, this is very important. The lock. So it gives a group of rows and the columns by the labels. Got it? By the labels, you get the things. Right. So that, let's say this is the bt.lock, and whatever the column whatever the rows you want, let's say we want something, the 11th row, the 14th row, the third row, right? Run this and you'll be getting first the 11th row, the 14th row, the third row, and like that. Okay, right? Now you can mention that you want a specific column and a specific row respectively, only a specific column and the specific rows, that is ranging, right? Ranging on your data frame. So before ranging will be going on later onwards, right? So that is how to range on your data set. Okay, is it clear? Anything like something, if you have doubts between the things in the locates, and anyone having any doubts?
Sir, like columns, can't we write like a BT of 0, comma 1, comma 2 index values?
uh, bt
Of
of
0, comma 1, comma 2. What we will get?
you want to write it like this? Okay, so you have to first like, you want to like write it like this or something else you're saying?
Sir, previously I have written like the columns you have written as a BT of players, comma span, comma.
Mm-hmm.
Why can't we write like index values
So
to get the
see,
rows?
you actually want to locate the index values. Okay, so you can write it like this.
Okay, sir.
This. So basically, you want to locate, like you want to locate some particular index. If you are locating with the names, that's nice, right? If you are just writing that locate the 11, 14, and 3, because there we have exactly these things. If you want to make something like, see, in the previous I said that you have a parameter for index columns too, right? for index column. That means from your data set, if you want to make something as your column, index column, you can make it there. Okay, right?
Okay, sir.
Like let's say that BT is there. If I say that there is GF, FG, right? And if it's not defined, the PT bathing average is there. Okay, so let's take a data frame and let's say data is bathing average, and I say the index column here. See guys, see clearly that I'm going to say the index column as player. Hmm? With something else unexpected. PLAYER. Uh, okay. Yep. All right. So like what you have to do is like first you'll have to like convert this. Let's say whatever the data frame is now for now. So I'm going to convert this in a CSV format, and I'm going to save it as batting average. Like it's for T20. Okay, batting average T20 dot CSV would be saved somewhere. Now FG will be PD dot read off under CSV, and this is going to be this paste and next columns to be player. Is that fine? Yeah. So now if I see the head of this FG, what you can find, the index column instead of this 0, 1, 2, 3 has got the player, right? So now I can easily write the FG of like R Ashwin, right? None of the type and the index of the columns. Oh, I'll have to locate it basically, right? So getting up to for the respective things. Now you can write up the, so as per your index you have to locate this. If you want to locate with the index number, you can still write that use I location and let's say 0, 1, whatever you want, locate it there. Okay, that is index location. So don't relate this with the 0 and 1 because that these are basically the index values, and there are methods for this lock index locations. Okay, right? So that is like if you want to slice on a rows, you can just use even find a thing like so you can make it like for BT. Let's say you want 0 to 3, 0 to 3. That means the first 3 rows like this. If you go, so if you don't want to use the locate, you can use this. Got it? My points. Like only the 3 values. Like so, this works as a head, guys. Okay, like a head. 0 to 4, the first 4 values. Got it? Okay. So if you say the BT, like to use, let's say to see some, to see multi columns, what you can say, right? So everything, and from there I only want, let's say, matches and the runs. That's it. Slice is an invalid key. Why? Oh. So what you can see, every row would be printed, right? And only the 2 columns will be there. All the things, all the rows and the things. If you want to locate even the rows, locate the first two rows and the first respective columns, right? And so does the things you can make it there. Like if I just make it above here, 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 and here, yeah. So to see, this is to find respective row and the respective column. Got it, guys? So to see a particular row and a particular column, you can use dot locate, write the row number, okay, and then give a comma, write the columns, and see the hell and whatever you want. Exactly. Like I have given for 0 and 1, you can take for 5, 8, whatever you want, and like there is no need for head because you're only taking the two things, right? So I'm deleting for these for now, right? Because you'll be confused with a bit of these things. Okay. Okay. So I believe going and iterating on your things and like locating and all those locations with the things might be clear to you, right? You can similarly go for the iLock too, right? If you see for the iLock, these are basically used for the index locations. Find the index locations uh, to find the rows using the index. You can use this. Even what you can do, guys, like bt dot locate. I locate. You can say like you want some respective like 5 or 6 and some respective first two columns, and like see player and the span kind of things, right? So you can do a lot of things like to see particular column and rows using iLock. You can use this, right? So I believe that these things will be clear to you, the location methods and all. We'll be continuing with the things from Monday. Okay.